Desktop computer. This is the classic setup most people picture when they hear the word computer, built around a separate tower or case that houses the processor, memory, and storage, with a monitor, keyboard, and mouse connected on the outside. Desktops trace back to the earliest days of personal computing in the 1970s and 80s, when machines like the Apple II and IBM PC brought computing out of research labs and into homes and offices. What sets a desktop apart is its expandability, since parts can be swapped, upgraded, or repaired far more easily than in most other computer types. That flexibility is exactly why desktops remain popular among gamers, video editors, and engineers who need serious power and don't mind the extra size. Laptop computer. A laptop takes everything found inside a desktop and compresses it into a single portable unit, with the screen, keyboard, and internal components all folded into one hinge-connected body. The concept began taking shape in the early 1980s, though early models were heavy and limited compared to what followed. Laptops differ from desktops mainly in their trade-off between portability and power. Since fitting components into a slim case means less room for cooling and upgrades, their importance comes from freeing computing from a single location, letting people work, study, or create from almost anywhere. Tablet. A tablet strips computing down to a flat touchscreen device with no attached keyboard or mouse, relying instead on fingers or a stylus for input. Devices like the iPad, released in 2010, popularized the modern tablet by proving that a simplified touch-first computer could still handle everyday tasks like browsing, reading, and media consumption. What makes tablets distinct is their operating systems, which are often built more like smartphone software than traditional desktop software, prioritizing simplicity over deep customization. They matter because they fill the gap between a phone and a laptop, offering a larger screen without the bulk of a full computer. Smartphone. Though often thought of separately, a smartphone is technically a full computer, small enough to fit in a pocket, combining processing power, storage, and internet connectivity into a handheld device. Its roots trace back to devices like the IBM Simon in the early 1990s, though the category truly exploded after the first iPhone arrived in 2007. Smartphones stand apart because of their constant connectivity and sensor-packed design, including cameras, GPS, and touch input all working together. Their significance lies in how they've become the primary computer for a huge share of the world's population, especially in regions where desktop ownership never became common. Server. A server is a computer built not for personal use but to provide resources, data, or services to other computers over a network. Servers have existed since the early days of networked computing, growing dramatically alongside the rise of the internet in the 1990s. What separates a server from a personal computer is its focus on reliability and uptime rather than everyday usability, often running without a screen or keyboard attached at all. Servers matter because they quietly power websites, cloud storage, and online applications that people rely on every single day, even if they never see the machines themselves. Workstation. A workstation looks similar to a desktop but is built with far more processing muscle, aimed at demanding professional tasks like 3D rendering, scientific simulation, or complex data analysis. These machines became especially prominent in the 1980s and 90s, used by engineers and designers who needed more precision and power than standard office computers could offer. The key difference lies in specialized hardware, including professional-grade graphics cards and support for massive amounts of memory. Workstations remain essential in fields like architecture, film production, and medical imaging, where mistakes or slowdowns can be costly. Mainframe computer. A mainframe is a large, powerful computer designed to process enormous volumes of data reliably, often used by banks, governments, and large corporations. These machines date back to the 1950s and 60s, when companies like IBM built room-sized systems to handle massive administrative and financial workloads. Unlike personal computers, Mainframes are built for extreme reliability and can run continuously for years without failure. Their importance lies in tasks few people ever notice, such as processing millions of transactions or managing critical records behind the scenes. Supercomputer. A supercomputer represents the extreme high end of computing power, built specifically to perform massive calculations at speeds far beyond ordinary machines. Early supercomputers emerged in the 1960s through pioneers like Seymour Cray, whose designs pushed processing speed to new limits. What defines a supercomputer is parallel processing, where thousands of processors work together simultaneously rather than one chip handling tasks alone. These machines matter enormously in fields like weather forecasting, space exploration, and medical research, where solving complex problems quickly can have real-world consequences. Embedded computer. An embedded computer is a small, specialized system built into another device to control a specific function rather than serving as a general-purpose machine. These systems became widespread starting in the 1970s as microprocessors grew small and affordable enough to fit inside everyday products. What makes embedded computers unique is their singular purpose, since they're designed to do one job extremely well rather than run multiple programs. They matter because they're everywhere, quietly operating inside cars, microwaves, medical devices, and traffic lights without most people ever realizing a computer is involved at all. Wearable computer. A wearable computer is designed to be worn on the body, most commonly seen today in smartwatches and fitness trackers. The idea gained real traction in the 2000s, with devices like the Apple Watch bringing computing power directly onto the wrist. These devices stand out for their compact sensors which track things like heart rate, movement, and location in real time. Their significance lies in blending computing directly into daily life and health monitoring, offering constant, low-effort access to information that once required pulling out a separate device entirely.